Here is the visual mnemonic representation of antimicrobial agents that inhibit peptidoglycan synthesis. And that's why you got the Pepsi bottle there. So it stands for peptidoglycan. You can start with cephalosporins, which is the cellophane here. And cephalosporins come from mold. They're bactericidal. They can be parenterally or orally administered. They have a side effect of hypersensitivity. It's in green because it's very wide spectrum, and it can be used for a lot of different gram-positive and gram-negatives. Bacitracin is produced by Bacillus subtilis, and here's a subbacteria. See? Subbacteria. And there's Tracy's back. So Tracy's back's right there. She inhibits peptidoglycan synthesis by preventing the attachment of amino sugars to cell membrane lipids. So she's kicking the sugar, the amino sugar, the mean sugar, and it's not attaching to these membrane lipids that are right there. It's just kicking it out. So the sugar cannot attach. Cycloserine, so you got the cyclo, is so serene. So cycloserine, it kills Mycobacterium tuberculosis, or TB, and that's why it's down there. And that's why it's orange, because TB does not gram stain, and so instead of having gram stain association, it's got it with something that doesn't gram stain. Very specific. It does have a central nervous system toxicity, so we can put in some question marks here. And central nervous system toxicity. It inhibits D-alanine, and these are a lot of the D's. They look like shovels, but D-alanine it inhibits. So the bacteria cannot make the cell wall because it inhibits the D-alanine and it can't use it. Right here we have the Beta-Lactam antimicrobial agents. These are the monobactams, penims, and carbapenems. You've got an M here on the back of this Beta-Lactam, and so that's the monobactam. And then you get the pens, the penims, and the carbapenems. So, but carbapenems can cause seizures, so that's one thing. But these stop the beta-lactam activity that often doesn't help the penicillins, which we'll get to, but the beta-lactam drugs stop those. And it's broad spectrum, used for a lot of different things. Over here you've got the inhibitors, and if you use them with the beta-lactam agents, they have a synergy, but it's the mentins or the sins. Timentin, augmentin, unisin, zosyn, so keep those things in mind. They inhibit the beta-lactam also. Go up here to penicillin. We've got a few different varieties. We've got the V, penicillin V, and just penicillin G mainly. It interferes with the synthesis of peptidoglycan. So there's the cap that's interfering with peptidoglycan, or Pepsi. It binds to the outer cell membrane proteins, the carboxypeptidases, or the transpeptidases, so it stops that, the outer cell membrane proteins. It can activate autolytic enzymes, and that's why there's a crack in the bottle, so it can make the Pepsi break down all by itself. And it's also bactericidal against actively multiplying cells. So G is pretty narrow spectrum, but used for gram positive. That's why it's in kind of this indigo purple. And V is narrow spectrum, but it can be used for some gram negatives. Penicillin oil. It's penicillin is the hapten that's responsible for hypersensitivity reactions. That might show up. It can cause GI disturbances, so that is a GI toxicity. And you get also, so you got the, you can be allergic to it or get GI disturbances. Vancomycin is the van, and you've got the sugar cubes, the mean sugar cubes, and the one that can't hear. Are you saying what? So let's go into kind of what the mode of action is for vancomycin. It inhibits transfer of amino sugars to the growing end of the glycopeptide on the cell wall. So it's stopping these sugars to get to the growing end. Here's the growing end. So it's kind of like running them over. It's bactericidal against multiplying bacteria. It does have nephrotoxicity, and I should put this in red. What? And the whole ear thing. It's a narrow spectrum, but gram-positive, mainly used for gram-positive organisms. And that's it. So the color coding, blue or indigo, is mainly gram-positive. Green is for Go. It's used for just about everything. It's broad spectrum. Orange are used for organisms that don't gram stain. And if we had pink would be for gram negative.